after getting this knowledge of alkane, now we are focusing on next part, that is the unsaturated one. In case of unsaturated, we are saying that at least one bond is either double bond or triple bond. Then we are calling that as unsaturated compound. Now, if one bond is double bond, this is I am going to show here, this is double bond, then compound is termed as al, and we are changing out prefix, suffix. Suffix means the word which is added at back. Here we are adding out ane, now we are adding out here ene. So we are adding out suffix as alkene. The formula is CnH2n. So here we are getting CnH2n plus 2, whereas here we are having formula only CnH2n. That plus 2 is removed. Why? See, there is carbon, carbon. So as two carbon atoms are there, we are calling that as ethene. Now valence is satisfied by single bond, but now I have to make here double bond. If I am making double bond, then carbon will have 5 bonds. It is not permitted. Carbon should have only 4 bonds, and therefore I have to remove this bond. So here there was already hydrogen and hydrogen. So as I am removing this bond, this hydrogen is gone, this hydrogen is gone. So what is remaining? That 2 hydrogens are less, then only double bond is possible. So I am removing out this 2 hydrogen. So whatever plus 2, we are writing here 2n plus 2. So whatever this plus 2, I have to remove here. Then this is the formula of alkene. So suppose C2, like that in this case, then H should be 4. So 1, 2, 3, 4. So like that compounds are here. So you are aware of now alkene. What is the category of characteristic of alkene? At least one double bond should be present. Now here this general formula is given when alkene is there. If second double bond is present in series, then we are calling that as diene. Third double bond is present, then triene. But right now don't go at that level. Only consider one double bond is there. Then this is the general formula. Now in this case, particularly alkene, the first member is absent. In alkane, that series, we discuss first member is C1H4, that is methane. But here we are not having methane. Reason is obviously, you are aware that what is alkene? There should be at least one double bond between carbon and carbon. So double bond should be there between carbon and carbon, then minimum 2 carbon atoms should be present, and therefore this series starts with ethene. So here the member is ethane, here similar member I should show ethene and not methane. So methane is not possible because there is only one carbon. But when 2 carbon atoms are there, it is possible. So first member is ethene, then propene, butene, like that. Everywhere we are adding out suffix as ene. Now what is the characteristic of this double bond? Say, you are aware now that double bonds, whenever I am showing double bond, one bond is sigma, another one is pi bond. Now in case of sigma bond, it is strong. In case of alkane, as there is only carbon-carbon single bond, only one bond, that means it is sigma. So alkanes are not showing that reactivity. Say, I am not showing alkane is not showing reactivity. You may say methane, we are using as fuel. It is combining with oxygen and giving us carbon dioxide plus water. It is shown, but it is not very reactive, whereas alkenes are somewhat more reactive than than alkane. Reason, say there is only sigma bond between carbon and carbon, which is difficult to rupture, but when pi bond is there, it is very easy to rupture, because bond breaking energy, that bond dissociation energy of pi bond is very less. we discussed that pi bond is formed because of lateral overlap of orbitals, pure orbitals, particularly here in case of carbon, they are pure p orbitals. And the overlap is not that strong. It is very easy to rupture bond with lower dissociation energy, and then see what happens. This bond is breaking out, so two sides are open because carbon should be tetravalent. Already carbon, in case of double bond, it is present. Then carbon is having these two valencies are not there. But now the moment I am removing this bond, there are two valencies open, so there is now chance that we are getting 4-4 bond. And so here, whatever the compound, suppose I am adding HCl, then H is added to one part and Cl is added to one part. And this way we are getting HCl is added. So alkene are giving this type of addition reaction. But we had to discuss this topic in later phase when we are discussing about types of chemical reaction. Now here alkane is not giving any addition reaction, but alkene, they are giving addition reaction very easily. Alkenes are more reactive than alkane because pi bond is easy to rupture. Pi bond is having very low bond dissociation energy. Now this is about alkene. Same way, if triple bonds are present, then that compound we are calling as alkyne. So here we are adding out suffix as YNE. So this is alkene, double bond. Any one triple bond is present, it is called as alkyne. Now alkyne is having general formula CnH2n, and now you are aware as one more pi bond is formed, two hydrogen atoms are removed. So from this formula, previous formula, I have to remove two hydrogen, so -2. So now you can compare general formula for alkane, it is CnH2n plus 2. For alkene, it is CnH2n, so two carbon less, two hydrogen less. Now here CnH2n minus 2, so whatever the total hydrogen is there, less than that 2. So again first member is ethyne. So this way these names propyne, butane, like that names are there for alkyne series. You are aware that we are using various compounds in this category also. For example, ethene. Ethene is undergoing one reaction, we are calling that as polymerization reaction. I am not giving detail here, just I am giving you example that ethene is undergoing reaction that is called as polymerization reaction, and we are getting polymer of ethene, and you are using that is polythene. Whatever the plastic, transparent plastic bags are we are using, they are called as polythene bags. So it is formed because of ethene. Then one of the important member of ethyne, we are calling that as acetylene. That is very reactive in nature. It is combining with oxygen, and it should be actually called as ethine, but general name we are calling acetylene. So it is giving flame that is called as oxyacetylene flame. That flame is having very high temperature, gas welding etc. We are using this type of high temperature flame for that is used as gas welding. So like that various compounds in these categories we are using in sometime daily life and sometime not daily, but in industries these type of things are required. So this is the classification of open chain compound. So basically we can say open chain compound I have to consider alkane, alkene, alkyne. But one step is there that we are calling saturated compound and unsaturated compound. Now we are going to closed chain compound. Now I have to remove this part, but you can keep this entire thing in your mind because it is required while discussing closed chain compounds also. Now we are focusing on cyclic compound or closed chain compound. They are divided basically into two parts. I should use suppose different color for that. We are calling that as alicyclic compound, and second, that is aromatic compound. Aromatic compounds are also cyclic compound, but they are having different categories. Usually you are aware that aroma, that means sort of fragrance. That's why the compound are named as aromatic compound. Whereas here we are calling this as alicyclic compound. They are again divided into same way. They are saturated and unsaturated. Whereas saturated, we have to add prefix. So what is here saturated compound in open chain, that was alkane. Now here we have to add prefix. Say it is called as cycloalkane. So A should be small. So they are calling cycloalkane. Unsaturated, you have to add again prefix as cycloalkene, cycloalkyne. Only that much is there about alicyclic compound. So you are now aware that cyclopentane can be there, pentane is there, cyclopentane, hexane is there, cyclohexane, like that. Now in case of aromatic compound, why we are calling this as separate? Because initially we were not having clear-cut structure of this type of compound. Particularly, name of compound is benzene. Its formula is C6H6. That means in our this type of term, we should call this as CnHn. Say carbon is tetravalent, hydrogen is monovalent, but still same number of this was indicating clear-cut high unsaturation. Unsaturation means more number of double or triple bond should be there in compound. And you are aware, if double bond is present or triple bond is present, then compound should give addition reaction. But to the surprise, benzene was not ready to give any addition reaction. You are aware of now addition reaction, that double bond because of pi bond is there, that is open out easily and give oxidation or whatever that is in form of addition reaction. But here they are not showing any property of unsaturated compound. That is the biggest problem, that why these type of compounds are not showing unsaturation. In spite of that, it is there. And then one fine day, a scientist named as Kekulé, he was able to get the structure of this type of benzene, particularly compound. He was trying to assign the compound. Say if I am assigning compound C6, says this is the 6, and I have to assign H. So H. Suppose, what is the probability? So can I shift one H here? Because carbon should have two double bonds. So as carbon should have carbon should have 4 bonds, but here we are showing only 2 bonds for carbon, 3 bonds for carbon. So can I add out unsaturation here? But that will give me another problem, that this is unsaturated. But benzene is not showing any test for unsaturation. Now like that he was thinking, I don't know, but in school days we used to hear this type of stories, that in dream that Kekulé observed some snakes holding their tail in their mouth. So he considered this as snake holding their tail in mouth. So he planned out this way now by getting what we can say inspiration is in dream. He said that God helped him in dream, etc. If that is true, I don't know. But this way he revealed the structure of benzene. Now this is possible. Now I am removing out this alicyclic part and we are focusing on aromatic part only. So 6 carbon I am placing in this way, whereas we are having single bonds everywhere. Now I have to place alternate double bond. So as there are alternate double bond, now observe every carbon check out, every carbon is having 3 bonds, and the fourth bond it is giving with hydrogen. So in this type of structure, we got 4 bonds for every carbon, and hydrogen is monovalent, it is there. Then question is there, as 3 alternate double bonds are there, why it is not showing unsaturation? You are aware, when double bonds are there, one bond is sigma, another bond is pi. Pi bond is having very low dissociation energy, so it should open out and form immediately compound, that is addition compound. So suppose I am adding HCl, HCl is this, then the expected compound here, if H is going here Cl, here H is going here Cl, and here H is going here Cl, and we should break out this alternate double bond. So this type of compound should be there, but it is not giving this type of compound. Like that, various problems are observed, and then they got answer in this way. What they are showing now, this is symbolically we are calling benzene ring with alternate double bond. Now you are aware, every terminal is having carbon atom and rest of bonds are with hydrogen. But they say that this is the way, they mean scientists, that this structure I can draw in this way also. Just check out, here single bond, here double bond, here double bond, here single bond. So these two structures are possible. That means double bond position is changed, and then we are calling this type of structure as a special type of structure that is called as resonating structure. I am revising the word, what we are calling resonating structure. That means the double bond is not fixed. Double bond is continuously changing out position. So this double bond will come here. At the same time, this will move here. So this way, bonding position are continuously changed out with these two. So this is possible structure 1 and this is possible structure 2. Practically, possible structure is different. That p bond, p pi orbital, what we are calling that p bonding is there. You are aware that p orbitals, pure p orbitals are forming this type of bond. So p pi orbitals are not stable, they are continuously moving here, and that's why we are getting a structure type that is called as resonating structure. That means delocalization of p pi orbitals. That will indicate me the bond is moving continuously and I am not able to locate out. Say suppose HCl molecule is there, it will not able to attack on p pi bond. Why? Because bonding position is continuously changing out. We are getting some different style of structure, and therefore if benzene ring is present in structure, we are calling that compound as aromatic compound. So getting idea. So this way benzene ring, this is a structure of benzene ring. Togetherly we are saying this structure is of benzene ring. We are showing hexagon and showing inside circle. That means p pi bond orbitals, they are now this is localized p orbital. This is called as delocalized p orbital. So this type of orbital, not orbital, bond. So this type of bond now is called as delocalized bond, and because of that we are having different bond length. Say this type of bond are having bond length less than single bond but more than double bond. So single bond length is different and double bond length is different, but when resonating structures are there, we are having something different. So this bond length is not equal to single bond and double bond. It is less than bond length of single bond but more than bond length of double bond, and so we consider that aromatic compounds we have to keep it separately. We are showing this is the benzene ring. All hexagon are occupied by carbon, rest of position by hydrogen, and then making circle inside. That means delocalized p orbital inside. So this is the explanation about aromatic compound. So this is aromatic compound, we are calling this as benzene. Now this is another aromatic compound This is one benzene ring which is attached this way to another benzene ring. We are calling this as naphthalene. You are aware naphthalene balls. Usually in toilet or wash basin we are putting out that white color ball that is made up of naphthalene. So this is the structure of naphthalene. This is benzene having liquid state at room temperature, but this is, you are aware, solid state at room temperature. If third benzene ring is attached over here, then we are calling this as anthracene, yellow colored fine powder, that is anthracene. So this is single ring benzene, double ring naphthalene, triple ring anthracene, and like that various compounds, like we are making rangoli, this type of designs are observed. We are calling that as aromatic compound. You must have observed about the peculiar smell of benzene. Then naphthalene also, you must have observed the intense smell given by naphthalene, and that's why these compounds are called as aromatic compounds. Now here, suppose I am moving out all these rings 2, whereas here is the hydrogen. All these valencies, you are aware now, they are satisfied by hydrogen. So one hydrogen is replaced by OH group. Then this category is called as phenol. No doubt this is not hydrocarbon, because hetero means different atom is introducing here, that is O. But still we are calling this as phenol, and this way this is also aromatic. That means if benzene ring is present, then we are calling that as aromatic compound. So this is the first part of organic chemistry. Here we just introduce about general classification of hydrocarbon. This we should consider as baseline classification, and then we have to develop new part in next lecture.